1, which is A times B, which is A times matrix B. We can see here matrix A is 2 by 3 matrix, and matrix B is 3 by 2. So 2 by 3 times 3 by 2 to get 2 by 2 matrix. So we will, after we multiply two of them, we will get a 2 by 2 matrix. Okay, so firstly, we use the first row of matrix A times the first column of matrix B, which will get this formula. And then for the 1, 2 of AB, we'll use first row of matrix A times the first column of matrix B. So we'll get this. For the 2, 1 of AB, we'll use matrix A's second row and the first column of matrix B. So we'll get 4 times plus. Since here is 0, so when we multiply, it's automatically 0. So we just take this one and do 2 times every 1. And then for our AB2 row, we use the second row of AB and second column of, second row of A and second column of B. So yes, 4 times 1. Same here is equal to 0, so we skip this. Plus 22 times 5. And we just simply solve this. We'll get 3 plus 4 and plus 3. That's our AB11. And AB12 is 1 plus 8 plus negative 15. And for our AB21, we'll get 12 plus 2. And our AB22, which is 4 plus negative 10. And we'll get here is 10. AB12 is negative 6 with 14 and negative 6. So that's our final answer for matrix A.
Good morning, Board of Judges! So now we will proceed to the second item, which is multiplying matrix B by matrix A. So you might be asking, why don't we just apply commutative property to the first item and get the same answer? Well, I will tell you that in multiplying matrices, we cannot apply the commutative property. Now here's why. Let's first define the dimensions of each matrix. So matrix B is a 1, 2, 3. It is a 3 by 1, 2, 2 column. 3 by 2 matrix rather. Now matrix A is 1, 2, 2 by 1, 2, 3. Matrix. Now, according to the rule in multiplying matrices, the column in the first matrix should be the same with the row in the second matrix. Now, 2 is the same as 2, so yes, we can multiply. Now, our answer should be a 3 by 3 matrix. Got it? So now we will begin solving. Now, I labeled this so we can easily trace it. Now, we will multiply b sub 1, 1 to a sub 1, 1. So, that will be 3 multiplied to 1. And we will add b sub 1, 2 multiply it to a sub 2, 1. So that will be 1 multiplied to 4. And by the way, the technique we use here is the diving board technique. Okay. So, we will continue. 3. And we will now multiply this b sub 1, 1 to a sub 1, 2, which is 2. So we will write it here. 3 multiplied by 2. Okay? So now we will multiply b sub 1, 2 to a sub 2. So that will be 1 multiplied to 0. And we will add that. Now the last one is b sub 1, 1 multiplied to a 1 sub 3. So that will be 3 multiplied to negative 3. Okay. And we will add b sub 1, 2 multiplied to a sub 2, 3. And that will be 1 multiplied to negative 2. And now we will continue that process here and here. So, it will be 2 multiplied to 1 plus 4 multiplied to 4. Got it? Okay. And then 2 multiplied to a sub 1, 2. And that will be 2 multiplied to 2. Plus 4 multiplied to 0. And then 2 multiplied to negative 3. Plus 4 multiplied to negative 2. Okay, now we're on the last one. And it will be b sub 3, 1 multiplied to a sub 1. And that will be negative 1 multiplied to 4. And we will add b sub 3, 2 multiplied to a sub 2, 1. Oh, I got it wrong. It should be a sub 3, 1 multiplied to b. B sub 3, 1 multiplied to a sub 1, 1. So it will be 1 times negative 1 times 1 plus 5 times 4. Okay, now negative 1 multiplied to 2. Plus 5 multiplied to 0. Now, negative 1 multiplied to negative 3. And plus 5 multiplied to negative 2. Okay, now we will be solving this. 3 times 1, 3 plus 1 times 4, 4. And then 3 times 2, 6 plus 1 times 0, 0. And then 3 multiplied to negative 3 is negative 9 plus 1 times negative 2 is negative 2. negative 1 times 2, negative 2 plus 5 times 0, 0. Okay. Now, negative 1 times negative 3 is 3. And the last one will be 5 times negative 2, which is 10. Now, for our final answer. 8 plus 4, 7. 6 plus 0, 6. Negative 9 plus negative 2 is negative 11. Now, 2 plus 16 is 18. 4 plus 0 is 4. Negative 6 plus negative 8 is negative 8. And then, negative 1 plus 20, 19. And then negative 2 plus 0 is negative 2. And last one, 3 plus negative 10 is negative 7. So now this will be our answer. Got it? Got it. Okay, now we will erase this on the board with the key. So when erasing a matrix board, we will erase it like this. Per row. Okay? Make sure that there is no row left behind. And there is this rule that only one direction. So you do this. 1, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, now it's all clean. Got it? Got it. So Francis already solved for AB. So we have here, we are going to find the matrix AB plus EF. So first, we go with this. We need to find the EF. So we have here, we multiply row 1 with column 1, which is 2 times 2 here and here, plus 3 times 4. And to the next one, we will multiply row 1 with column 2. So we also have 2 again, multiplied to negative 3 plus 3 multiplied to 1. So we go on further with row 2 that multiplied to column 1. We have negative 1 multiplied to 2 plus negative 2 multiplied to 4. And next, row 2 multiplied to column 2. So this is our row 2. We multiply negative 1 with negative 3 plus negative 2 multiplied to 1. So we are going to solve this. So 2 times 2 is 4 plus 3 times 4 is 12. We have here 2 times 3 is negative 6 plus 3 times 1 is positive 3. So next we have negative 1 multiplied with 2 is negative 2 plus negative 2 multiplied with 4 is negative 8. And negative 1 multiplied by negative 3 is positive 3 plus negative. So we get the summation, the sum of all the numbers, of all the values. We have 4 plus 12 is 16. Negative 2 plus negative 8 is negative 10. Negative 6 plus 3 is negative 3. And 3 plus negative 2 is 1. So now, since we have all the values of A and AB plus BF, and so we write down the value, the matrix AB, which is 10, 14, negative 6, negative 6. And we add it to the value matrix of BF, which is 16, negative 10, negative 3, and 1. So we add it all. We add 10, We had 10 plus 16, negative 6 plus negative 3, 14 plus negative 10, and negative 6 plus 1. So we add the values. We have here 10 plus 16 is 26, 14 plus negative 10 is positive 4, negative 6 plus negative 3 is negative 9, and negative 6 plus 1 is negative 5. So AB, our new matrix is 26, 4, 9. Okay, so now let's proceed and let's solve for BA plus BF. Thankfully, Eunice already solved for BA in number 2, so it's easier for me. So let's proceed to solving for BF. So let's copy it. Okay. BF is equal to copy D 2, negative 1, 3, negative 3 times F, which is 2, negative 3, 4, 1. Now let's do the diving method. So basically diving method is this part here, you multiply it with this part here. Okay? So we'll have 2 times 2 plus 3 times 4. That's it. Next, we dive again. This row multiply to this column. 2 times negative 3 plus 3 times 1. Let's just close it. Okay? Next, this row, you multiply it to this column. Negative 1 times 2 plus negative 2 times 4. And lastly, this row to this column. 1 times negative 3 plus negative 2 times 1. Okay, so double check if you got the correct values. 2 times 2, 3 times 4, 2 times negative 3, 3 times 1. Next, negative 1 times 2, negative 2 times 4, and negative 1 times. Okay, so I got the wrong value here. Negative 1 times negative 3, and negative 2 times 1. So it's important that you really check your values. So we have EF is equal to 4 plus 12. Next we have negative 2 minus 8. Next we have negative 6 plus 3. Next we have 3 minus 2. Okay, double check. And finally, EF is equal to 16, negative 10, negative 3, and 1. Okay, so let's continue. Now that we have the value of DF, let's proceed in adding DA to DF. So we have over here, DA plus DF is equal to, copy the values of DA. We have 7, 6, 11, 18, 4, negative 14, 19, negative 2, negative 7. Plus DF, which is this. So we copy it. 16, negative 3, negative 10, and let's correct this out. So as you can see, DA is a 3 by 3 matrix, while DF is a 2 by 2 matrix. And because they have different dimensions, we cannot add them. It's not possible. Even if we transpose 3 by 3 or we transpose 2 by 2, it's not possible. Therefore, we cannot add DA and DF. So that's all.
So my given matrix or my given problem is matrix A times matrix B and D. So first, by order of class, we're going to multiply inside the parentheses. So we see that matrix B is a 3 by 2 matrix and matrix D is a 2 by 2 matrix. We can only multiply matrices if they have the same number of So if we multiply matrix B by matrix D, we are going to have a matrix which has 3 rows and 2 columns. So in my own process, I'm going to write the column 1 of matrix B, which is 2 and negative 1. Then I'm going to multiply these two values by each row in matrix B. Row 1 of B, when multiplied with these two values, we're going to have 2 times 3 plus negative 1 times 1. Then we have 6 plus negative 1, which gives us 5. Next, row 2 of B, we have 2 times 2 plus negative 1 times 4. So we have 4 plus negative 4, which gives us 0. Last, row 3 of B, 2 times negative 1 plus negative 1 times 5, which gives us negative 2 plus negative 5. When added, we have negative 7. Now that we've found our first 3 values, we are going to do the same, but we're going to do it with the column 2 of matrix D. We're going to write column 2 of B, which have the values of 3 and negative 2. Do the same process, multiply by each row in matrix B. We have 3 times 3 plus negative 2 times 1, which gives us 9. 9 plus negative 2, which gives us positive 7. Row 2 of matrix B, 3 times 2 plus negative 2 times 4. We have 6 plus negative 8, which gives us negative 2. Row 3 of matrix B, 3 times negative 1 plus negative 2 times 5, which gives us negative 3 plus negative 10 equals negative 13. Now that we found the values of the product of matrices B and D, we're going to arrange them. B, we simply copy 5, 0, negative 7, 7, negative 2, and negative 13. Now we're going to find out if the product of matrix BD can be multiplied to matrix A. So we know that matrix A has a dimension of 2 by 3 and matrix BD has a dimension of 3 by 2. Now remember, we can only multiply matrices if these numbers inside are the same. So we can indeed multiply them. And the dimension of what we expect their product will have a dimension of 2 by 2. Now that we know we can divide matrix BD and matrix A, we're going to write column 1 of BD, which have the values of 5, 0, and negative 7. These values we will multiply in each row in matrix A. So we write row 1 of A, 5 times 1 plus 0 times 2 plus negative 7 times negative 3, which gives us 5 plus 0 plus 21, with a total of 26. Then we do the same for row 2 of column of matrix A. 5 times 4 plus 0 times 0 plus negative 7 times negative 2, which gives us 20 plus 0 plus 14, giving us 34. Now we do the same, or we copy column 2 of BB, column 2 of BB, which have the values of 7, negative 2, and negative 13. We do the same thing, we multiply by each row in matrix A. Row 1 of matrix A, 7 times 1 plus negative 2 times 2 plus negative 13 times negative 3, giving us 7 plus negative 4 plus 39, which gives us 42. Then, last, for row 2 of matrix A, 7 times 4 plus negative 2 times 0 plus negative 13 times negative 2, giving us 28 plus 0 plus 26, which gives us 54. Now that we found the 4 values, we can now arrange them. A times matrix BB gives us a matrix of, simply follow column 1 of row, column 1 row 1 is 26, column 1 row 2 is 34, column 2 row 1 is 42, and column 2 row 2 is 54, which is the final answer for A times B.
Okay, so now let's do AB times B. So earlier, Francis solved for AB. So the answer is 10, negative 6, 14, and negative 6. So now let's multiply these two by 2 matrices. So let's do the diving method. That is 10 times 2, negative 6 times negative 1, 10 times 3, negative 6 times negative 2, 14 times 2, and negative 6 times negative 1, 14 times 3, and negative 6 times negative 2. So let's solve. That is 20 plus positive 6, 24 plus positive 6, 30 plus positive 12, 40 is 42 plus positive 12. So let's add 26, 30, 42, and 54. So that is AB times B.
So we have here a given of A times C plus A. So first, let's solve for C plus A. So as you can see, our matrix C is 3 by 3. And our matrix A is 3 by 3. So we can add them together. So C plus A is equals to 2 plus 1, 3 plus negative 2, and 1 plus 3. 3 plus 0, negative 4 plus 1, and negative 1 plus 4. 1 plus negative 3, 5 plus 5, and negative 2 plus 2. So C plus E equals to 2 plus 1 is 3. 3 plus negative 2 is 1. 1 plus 3 is 4. 3 plus 0 is 3. Negative 4 plus 1 is negative 3. Negative 1 plus 4 is 3. 1 plus negative 3 is negative 2. Plus 5 plus 5 is plus 10. And negative 2 plus 2 is 0. So now we can multiply matrix A to C plus A. So as you can see, our matrix A here is 2 by 3. And our C plus A matrix is 3 by 3. So now, we have a new dimension of 2 by 3. So now we can solve A times C plus A. So from row 1 to column 1. So 1 times 3 plus 2 times 1 and negative 3 times 4. Again, row 1 to column 2. 1 times 3, 2 times negative 3, and negative 3 times 3. So last is row 1 to column 3. So we have 1 times negative 2, 2 times 10, and negative 3 times 0. Next, we have here row 2 to column 1. So 4 times 3 plus 0 times 1 and negative 2 times 4. From row 2 to column 2. So 4 times 3, 0 times negative 3, and negative 2 times 3. Plus row 2 to column 3. We have 4 times negative 2 plus 0 times 10 and negative 2 times 0. So we can multiply that. So 1 times 3 is 3 plus 2 times 1 is 2 and negative 3 times 4 is negative 12. Then 4 times 3 is 12. 0 times 1 is 0 and negative 2 times 4 is negative 8. Then 1 times 3 is 3 plus 2 times negative 3 is negative 6 and negative 3 times 3 is negative 9. 4 times 3 is 12. 0 times negative 3 is 0 and negative 2 times 3 is negative 6 plus 1 times negative 2 is negative 2. 2 times 10 is 20 and negative 3 times 0 is 0. 4 times negative 2 is 8, negative 8 plus 0 times 10 is 0 and negative 2 plus 0 is 0. So now we can add them together. So 3, C plus E. So 3 plus 2 plus negative 12 is negative 7. 12 plus 0 plus negative 8 is 4. 3 plus negative 6 plus negative 9 is 12. And negative 12. 12 plus 0 plus negative 6 is 6. Negative 2 plus 20 plus 8. 8 plus 0 is 18. And negative 8 plus 0 plus 0 is negative 8. So here is the answer for 8 times C plus E.
Now, let's solve for AC plus AP. First, let's solve for AC. So matrix A has a dimension of 2 by 3 and matrix C has a dimension of 3 by 3. So let's solve for so our new dimension is 2 by 3. Now, let's multiply A and C. First is, let's multiply the first row of A to the first row of C. So AC is equal to
1, 1 times 2 plus 2 times 3 plus negative 3 times 1.
Next step, steal the first row of A to the second column of C.
So 1 times 3 plus 2 times negative 4 plus negative 3 times negative 1. Next is steal the first row of A to the third column of C. So we have 1 times 1 plus 2 times 5 plus negative 3 times negative 2. Next step is the second row of A to the first column of C. So we have 4 times 2 plus 0 times 3 plus negative 2 times 1. Next, steal the second row of A to the second column of C. So we have 4 times 3 plus 0 times negative 4 plus negative 2 times 1. Negative 1 ganit. Next is steal the second column of A to the third column of C. So we have 4 times 1 plus 0 times 5 plus negative 2 times negative 2. Okay, so let's multiply that. 1 times 2 is 2 plus 2 times 3 is 6 plus negative 3 times 1 is negative 3. Next, 4 times 2 is 8 plus 0 times 3, 0 plus negative 2 times 1 is negative 2. Next, 1 times 3, 3 plus 2 times negative 4 is negative 8 plus negative 3 times negative 1 that will become positive 3. Next, 4 times 3 is 12 plus 0 times negative 4 is 0 plus negative 2 times negative 1 will become positive 2. 1 times 1, 1 plus 2 times 5 is 10 plus negative 3 times negative 2 is positive 6. 4 times 1, 4 plus 0 times 5, 0 plus negative 2 times negative 2 is positive 4.
Let's add them together.
So 2 plus 6 plus negative 3 is 5. 8 plus 0 plus negative 2, positive 6. Next, 3 plus negative 8 plus 3 is negative 2. 12 plus 0 plus 2 is positive 14. 1 plus 10 plus 6 equals to 17. And 4 plus 0 plus 4 is 8. So that is A times C.
Now let's solve for A times E. A matrix A has a dimension of 2 by 3 and matrix E has a dimension of 3 by 3. So their new dimension is 2 by 3. Now let's solve for AE. The process is still the same as the first one. So AE is equals to the first row of A to the first column of E. So 1 times 1
plus 2 times negative 2 plus negative 3 times 3.
Next is still the first row of A to the second column of B. So 1
Times 0 plus 2 times 1 plus negative 3 times 4.
Next, still the first row of A
To the third column of B. 1 times negative 3 plus 2 times 5 plus negative 3 times 2. Next, the second row of A to the first column of E. So 4 times 1 plus 0 times negative 2 plus negative 2 times 3.
Next, still the second row of A, the second column of E. So 4
Times 0 plus 0 times 1 plus negative 2 times 4.
Next, last one.
The second row of A to the third column of E. So 4 times negative 3 plus 0 times 5 plus negative 2 times 2.
Now let's multiply them together.
1 times 1 is 1 plus 2 times negative 2 is negative 4 plus negative 3 times 3 is negative 9.
Next, 4 times 1 is 4.
Plus 0 times negative 2 is 0 plus negative 2 times 3 is negative 6.
Next one.
1 times 0 is 1 plus 2 times 1 is 2 plus negative 3 times 4 is negative 12 and 4 times 0 is 0 plus 0 times 1 is still 0 plus negative 2 times 4 is negative 8. Next one, 1 times negative 3 is negative 3 plus 2 times 5 is 10 plus negative 3 times 2 is negative 6. 4 times negative 3 is negative 12 plus 0 times 5 is 0 plus negative 2 times 2 is negative 4.
Now, let's add them together.
So 1 plus negative 4 plus negative 9 is negative 12. 4 plus 0 plus negative 6 is negative 2. 1 plus 2 plus negative 12 is negative 10. 0 plus 0 plus negative 8 is still negative 8. Negative 3 plus 10 plus negative 6 is 1. And negative 12 plus 0 plus negative 14 is negative 16. So, this is the product of A times C.
So earlier, we solved for AC and AE. Now we add them together.
So, AC plus AE, 5 plus negative 12, 6 plus negative 2,
Negative 2 plus negative 10. 14 plus negative 8. 17 plus 1. And 8 plus negative 16. Now let's add them together.
so AC plus AE is equals to 5 plus negative 12 is negative 7.
6 plus negative 2 is 4. Negative 2 plus negative 10 is negative 12. 14 plus negative 8 is negative 6, positive 6. 17 plus 1 is 18. 8 plus negative 16 is negative 8. So that is the final answer.